Hello everyone. Today we have the most important topic related to the real-time big data analysis system resulting from Internet of Things, presented by Mohammed Makarem and my friend Munif Abdullah Razaz. We are Master of Science in King Fahd University of Petroleum and Minerals QVM in Saudi Arabia. So let's start. First of all, we have the outlines, introduction, and background. The research problem and research goals. Another one is used research principles, IoT and smart environment, also big data. After that, framework of for big data processing, Spark and Hadoop, overview and components, primary distinction between Hadoop and Spark. Also, the lecture review in general data and in IoT data. Another move to methodology, comparison setup, and performance testing. Before the last results, we will see the results. After that, conclusion. So, start in the introduction. This research problem. What's the problem of our research? Increasing IoT data complexity as the number of IoT devices grow. Handling drives and massive data in real time becomes challenging. So the importance of real-time analytics. Companies require efficient real-time analytics for timely discussion making. So the research goal. What's the research goal? Objective in our objective is evaluate data analysis system for large-scale IoT data. Focus assess efficiency and suitability of a Beach Spark and Beach Hadoop framework. This figure shows the number of connected IoT devices from 2019 to 2030. We'll see in the figure 1 and figure 2. I also used research principle IoT and smart environment. Definition IoT as interconnected system providing unique identifiers for devices. Smart environment integration of devices for enhanced human comfort. So, in the big data definition, large and complex data sets requiring advanced technologies, the importance enhances decision-making processes across various fields. So, the framework for big data processing, Spark and Hadoop. The Hadoop overview for the Hadoop is distributed processing using map-reduce algorithm. Component HDFS, map-reduce, yarn, and Hadoop Camel library. Spark, overview for the Spark, high performance data processing on supporting various workloads. So the components Spark Core and Spark Streaming, Spark SQL, MLIB, and GraphX. So the primary distinction between Hadoop and Spark is performance comparison. Spark significantly faster, leveraging in memory processing. The cost and resource utilization Spark more cost effective, utilizing less hardware. The scalability in both frameworks scalable, but Spark excel in real-time processing. The machine learning Spark in memory calculation make it faster, more machine learning algorithm. But the Hadoop with the Spark use case, the Hadoop use case infrastructure setup on budget, batch processing historical data. The Spark use case real-time streaming, data analysis, fast results, machine learning. So in our lecture review, general data and IoT data. In general data, the retail sector, a B Spark used for Black Friday sales prediction. Sentiment analysis Hadoop employed for sentiment analysis on Twitter data. But IoT smart cities framework leveraging map reduced for IoT data processing. Energy management system EMS IoT data used in optimizing energy consumption. A smart tourism three-site system combining IoT and big data analytics in Toronto, Italy. Air quality prediction Spark and MLab used for prediction air pollution from IoT sensors. In the healthcare, monitor IoT and big data analysis for remote patient monitoring. Also, industrial sector, Hadoop and machine learning tools for fault prediction. So, what is the methodology in our research? Comparison setup. Dataset utilize IoT from US Environment Protection Agency. Pre-processing use Pandas library for data calling and analysis. Framework and tools Spark 3.11 with 3.11 and one with the Jupyter Hadoop 3.1.1 with Windows 10 command prompt. Performance testing, statistical information. In the statistical information execution time, comparison Spark outperformed Hadoop 67 seconds, visit 156.27 seconds. المachine learning operations, random forest classifier Spark performed significantly better 67 seconds, visit 240 seconds. Decision tree classifier Spark again outperformed Hadoop 55 seconds, visit 90 seconds. In the data follow, streaming data analysis Spark demonstrate real-time data processing capabilities. In our result, execution time framework, execution time in second in the first column and the second column. In the first column, we have the Al-Hadoop, map reduce. Execution time in 156.27. Framework Spark, the execution time is 67. We see in this figure execution time in seconds, time taken off to perform the task. Observation, Hadoop took twice the time of Spark for the same task. Hadoop 2 minutes and a few seconds. Spark 1 minute and a few seconds. Second experiment, iterative process random forest classifier execution time. Hadoop 140 seconds. Spark 67 seconds. Decision tree classifier executive time. Hadoop 90 seconds. Spark 58 seconds. Machine learning performance Spark consistently outperformed Hadoop in both machine learning algorithm. So this figure show the execution time of machine learning. We can see the random forest and decision tree for Spark and Hadoop. This execution time of machine learning method. The third experiment, data follow. Real-time streaming data processing. Spark demonstrated speed and responsive. Also, live chart showcased Spark ability to handle streaming data. Spark ability to operate slowly in memory without restoring to hard disk using contributed to its speed advantage. This figure show the following NO2 gas values. The new values of NO2 gas upon arrival. The y-axis the NO2 received value, and the x-axis the moment of arrival. We show this figure. Our conclusion framework suitability for IoT data. First is Spark advantage, faster execution time, efficiency, resource utilization, superior performance in iterative processes, real-time data processing capabilities, cost effective. Implementation for IoT data analysis significant as IoT and complexity grows. Appropriate big data framework become crucial, and recommendation Spark identified as more appropriate framework for large scale streaming IoT data analysis. The future implementation, continued growth of IoT data as IoT data volume and complexity increase. The choice of an efficient framework becomes prominent. Research and development ongoing studies should explore advantage in big data framework to address evolving IoT data needs. The recommendation and future work, adoption of a bit Spark for real-time analysis Spark in memory processing and streaming capabilities make it ideal. Also, machine learning applications, superior performance in machine learning tasks. Also, consideration of a specific use case, Hadoop Spark in the Hadoop batch processing, historical and archival data analysis, and Spark real-time streaming data analysis, machine learning applications. So, the future work, enhancement and innovations, framework evaluation and integration of advanced technologies. In the framework evaluation, continuous improvement and innovation in both Hadoop and Spark. integration of advanced technology, exploration of emerging technologies for enhanced IoT data processing. Thank you for listening. Any question? And this is the reference. Thank you so much for your attention.